Graphing quadratic functions. Today's objectives will be, number 1, to graph quadratic functions, and number 2, to find and interpret the maximum and minimum values of a quadratic function. Mathematical practice number 1, make sense of problems and persevere in solving them. Quadratic function. Greatest exponent is 2. Examples would be 3x squared, ax squared, negative 7x squared. General quadratic function can be shown as f of x equals ax squared plus bx plus c, where a does not equal 0. If a equals 0, then we wouldn't have the quadratic term in the front, so then it wouldn't be a quadratic function. A parabola is the graph of a quadratic function. Let's take a look at an example of graphing a quadratic function. So the example says graph f of x equals 3x squared minus 12x plus 6 by making a table of values. So here's my table. I'm going to choose a few x values. So we'll go 0, 1, 2, 3, and 4. So once I pick my x values, then I can substitute my x values into my function f of x up here and calculate my f of x, or my f of x. So we start with 0. So 3 times 0 squared minus 12 times 0 plus 0. I'm just substituting in my x values into my function. So I get 0 minus 0, 0 plus 6 is 6. I'm going to do the same thing with 1. So 3 times 1 squared minus 12 times 1 plus 6. 1 squared is 1, so that's 3 minus 12 plus 6. 3 minus 12 is negative 9 plus 6, so that's a value of negative 3. For 2, I'm going to get a value of negative 6. 3, I'm going to get a value of negative 3. And then lastly, when I put 4 in, I get a value of 6. So to save some time, I'm not going to show you all of those calculations, but these are the actual coordinates that we want to now plot on a coordinate plane. All right, now that I've got my coordinates from my calculations, again, I picked my x value, plugged it into my function here, and got my f of x value. So now I'm going to plot these points on my graph. So 0, 6. I'm going to start at the origin, and I don't go left to right because there's no x values, so then I'm just going to go up 6, 1, 2, 3, 4, 5, 6, and put a point. Next coordinate, 1, 3, so back to the origin. I move to the right 1 and down 3. 1, 2, 3. Put a point. 2, negative 6. Back to the origin. I'm going to go right 2 and down 6. So 1, 2, 2, 3, 4, 5, 6. Okay. Next one is 3, negative 3. So I'm going to go to the right 3 from the origin and down 3. So 1, 2, 3. Then down 3. 1, 2, 3. And then my last coordinate is 4, 6. Again, back to the origin. I go to the right 4 and up 6 because now they're both positive. So 1, 2, 3, 4, 2, 3, 4, 5, 6. Once I got all my points graphed, I can connect the dots and make my graph of this quadratic function. So there's my graph. A parabola is a smooth, continuous curve. Now I would like for you to pause the video and practice this problem in your notes. I would like for you to do this practice problem in your notes as well. Next vocabulary word, Axis of symmetry. This is a line through the graph of a parabola that divides the graph into two congruent halves. Just a side note, each side of the parabola is a reflection of the other. Vertex. The only point where the axis of symmetry will intersect a parabola. If we look at the graph of the first example, you can see that the vertex is at the bottom of this parabola and its coordinate is 2, -6. And then you can also see the dotted line through the middle of the parabola is your axis of symmetry. And that equation for that line is x equals 2. When graphing quadratic functions, here are some key points to remember. So if we consider the graph of the quadratic function y equals ax squared plus bx plus c, where a does not equal 0, we can look at the y-intercept. If I replace my x value with 0, then a times 0 squared is 0 plus b times 0, which is 0. So all I'm left with is c, which is just a constant. That'll be my y-intercept. The next thing to remember is the equation for the axis of symmetry. We can find that to be x equals -b over 2 times a. b and a are the coefficients on the linear term and the quadratic term of your quadratic function. And the last thing to note is the x-coordinates of the vertex can be found by using -b over 2a. Let's look at an example of finding some information off of a quadratic function. So example 2 says, consider the function, so that's f of x equals x squared plus 4x minus 3. First thing we want to do is find the y-intercept. So before I actually start this, I want to make sure my function is in standard form, and it is, so we have our quadratic term first, then our linear term, and then our constant. So the form of the function is fine, so now we can get some information off of that function. So if I want to find the y-intercept, that means I'm going to let my x values be 0, okay? Because when I find an intercept, that means the other part of the coordinates is 0. So in my function, I'm going to replace x with 0. Okay, so we've got 0 squared plus 4 times 0 minus 3. Well, 0 squared is 0 plus 0, so 0 minus 3 gives me a value of -3. So I can say my y-intercept is -3. All right, the next thing we want to look at is part B. Consider still the same function. And find the equation of the axis of symmetry. So what I've done was I have taken the coefficients off of my function. So the a coefficient is this one in front of my x squared. My b is the coefficient in front of my x, and then my c is just my constant. So in order to find the axis of symmetry, I need my coefficients, my a, b, and c. Then I have my equation to find that axis of symmetry. So x equals -b divided by 2 times a. So let's fill in our numbers from that function. So x equals -b, that's -4, over 2 times a, so a is 1. So I've got -4 over 2, so that gives me a -2. So the equation for my axis of symmetry is x equals -2. Now, this is also my x-coordinate for my vertex. Next up, with our function, we want to make a table of values that includes the vertex so that we can graph our quadratic function. Just a couple of pointers. When you make a table, you want to select 5 points. Make sure you have the vertex in the middle and then 2 points on either side of the vertex. So a point to the left of the vertex and a point to the right of the vertex, which is including the y-intercept and its reflection. All right, so you can see the table I have set up. I have my x values to the left that I chose. -6, -4, -2. That's my vertex that we calculated just a few seconds ago. And then you can see the next entry, which is x is 0. That's my y-intercept. And then another number of 2. So I substitute all those values into my function, which you see in the middle column, and then that gives me my f of x value, which is the column to the right. All right, so what I have done is I have taken my x values from the table and my f of x values, because those are the coordinates that I'm going to plot in order to graph my quadratic function. I've got my graph right here. I already marked off my axis of symmetry going through x equals -2. So let's plot my coordinates. So for each one, I'm going to start at the origin. I'm going to move left to right first and then up and down. Then that's where I'm going to put my coordinate or my dot. So these two coordinates are the reflections of each other along with these two coordinates. So one is the reflection of the other because they are the same distance from the axis of symmetry on each side. So once I've got my 5 coordinates on my quadratic function, I'm going to do the best I can to make this a smooth curve. So this would be the quadratic function of x squared plus 4x minus 3. Let's take a look at another example. So consider f of x equals -5x minus 10x plus 6. So a couple of things we're going to look at is, first thing, the y-intercept. So when I want to find the y-intercept, that means my x value is 0. So if I were to plug 0 into my function, I would get -5 times 0 squared minus 10 times 0 plus 6. Well, that's 0, that's 0. So all I'm left with is my value of my c, which is down on the end there. That's positive 6. So my y-intercept is 6. The next thing I want to do is look at the equation for my axis of symmetry. So once again, I can calculate my axis of symmetry by using this equation, x equals that -b divided by 2a. So let's figure out what my a, b, and c are from my function. So my a is the coefficient on my x squared term, so that's -5. My b is the coefficient on my x term, so that's a -10. And then c, we'll just go ahead and write that down. That's that number, the constants at the end of the function, so that's a positive 6. Once I have these, now I can just substitute the values I need into that x equals. So x equals -b, so b is a -10, so I make sure I don't drop one of those negatives, divided by 2 times a, well, a is -5. So I got x equals negative gives me a positive 10, divided by 2 times -5, that's -10. So 10 divided by -10 is a -1. So the equation for my axis of symmetry is that x equals -1. Now, as we saw earlier, once we find the axis of symmetry, that x coordinate or that x value is the x value for the coordinates. All right, so what we had to do next was make a table of values, including your vertex. So you can see I've marked that there, and I've also got your y-intercept included in that table. So once you pick your x values, calculate your f of x, then you can see to the right I have plotted all those points and did the best that I could to make a smooth, continuous graph. Notice our quadratic function is negative, so it opens down instead of up. Now I would like for you to pause the video and work on practice problem number 3 in your notes. Next vocabulary word, we have maximum value or minimum value. So these would be the y coordinate of the vertex of a quadratic function. And just a side note, these values represent the greatest or lowest possible values the function can reach. So here's a visual of what's happening with a quadratic function, ax squared plus bx plus c, where a does not equal 0. So if a is positive, then your parabola opens up and you have a minimum value. If your a is negative, then your parabola will open down and you will have a maximum value. Example number 4. Consider f of x equals negative 4x plus 12x plus 8. First, we want to determine whether the function has a maximum or minimum value. So in order to determine that, I need to know what the coefficient on my quadratic term is. So my quadratic term would be my first term of negative 4x squared. So because my coefficient is a negative 4, that means that I have a maximum value and my parabola will open down. Next, we are asked to state the maximum or minimum value of this function. So in part A, we found out that we have a maximum value, okay, because this parabola will open down, so it's going to have a maximum value at the top, okay? So in order to find that maximum y value, okay, we have to find the x value of this coordinate first. So we saw earlier that we can calculate the x value of that coordinate by using that x equals negative b over 2 times a equation. So what I've already done is picked out the a, b, and c from my function up here. So I'm going to substitute those in. So I get negative b, which is negative 12, over 2 times a negative 4. So that gives me negative 12 over negative 8, which gives me a value of 1.5. Okay. So now that I have my x value, what I can do is substitute my x value into my function to find my y value. So let's do that. So I've got f of x equals negative 4 x squared, but that's now 1.5. So 1.5 squared plus 12 times 1.5 plus 18. So if I calculate all of this, I will get my f of x value or y value at 27. So to answer this question, state the maximum value. The maximum value of this quadratic function is f of x equals 27. And the last part of this example says to state the domain and range of the function. So what I've done off to the side is I've kind of given a rough graph of this quadratic function. So our domain is the values of x, so that's our x-axis values, and then the range is your y values. So the domain of this quadratic function can be any real number on that x-axis. Okay. Because my graph continues on from left to right to infinity, then that's why we can say all the real numbers would satisfy the domain. Now, the maximum value or the range of this graph will only go up to 27. We found that the maximum value in the last part was 27, so therefore the range is from the lowest point in the graph, which is infinite, to the highest point in the graph, which is our maximum at 27. So we can write that as, okay, our range is all my y values that are less than or equal to 27. And now I would like for you to pause the video and work on practice problem number 4 in your notes.